Partitions and replication are the architecture, but producers and consumers are what you actually write. This is where the rubber meets the road, where the choices you make in a few config lines decide whether you lose data, double process it, or nail it. Let's go through the decisions that matter. Start with the producer and the acknowledgement setting we touched on before. Acknowledgement set to 0. Fire and forget, no waiting, data loss on any failure. Set to 1. Wait for the leader only, but you lose data if that leader dies before its followers copy the write. Set to all. Wait for all the in-sync replicas, and now you don't lose data. For anything important, it's acknowledgements all, no debate. But acknowledgements all plus retries creates a subtle bug. Picture it. The producer sends a message, the broker actually commits it, but the acknowledgement gets lost on the way back. The producer, hearing nothing, retries, and now you've got a duplicate sitting in the log. Annoying. The fix is the idempotent producer. You turn on one setting, enable idempotence, and the broker starts assigning each producer an ID and tracking sequence numbers per partition. If it sees the same producer and the same sequence number twice, it silently drops the duplicate. You get exactly once writes within a partition session, for free. Turn it on. One more producer knob. Batching. Producers group messages together before sending to be efficient. 2 settings control it. Linger time. How long to wait to fill up a batch before sending. And batch size. The maximum bytes per batch. If you need low latency, like real-time scoring, set the linger time to 0. Send immediately. If you're optimizing for throughput, like an analytics pipeline, set a small linger, maybe 20 milliseconds, to pack fuller batches. Latency versus throughput, in one setting. Now the consumer side, and the single most important decision you'll make. When do you commit your offset? Remember, the offset is your bookmark. It tells Kafka how far you've processed. And the order of operations here is everything. If you process the message first, and then commit the offset, you get at least once delivery. Why? Because if you crash after processing, but before committing, you'll reread that message on restart and process it again. Duplicates. Which is fine, because your consumers are idempotent, right? We covered that. But if you commit the offset first, and then process, you get at most once. Because if you crash after committing, but before processing, that message is gone forever. You told Kafka you handled it, and you didn't. That's data loss. So the rule: process first, commit second. And critically, avoid auto-commit for anything important, because auto-commit can commit an offset before your processing is actually done, silently losing messages on a crash. Poll your messages, do the work, then commit, in that order. Let's talk consumer groups, because this is how you scale reading. A consumer group shares a topic, and each partition goes to exactly one member. So if you have a topic with 6 partitions and a group with 3 consumers, each consumer handles 2 partitions. Add a 4th consumer, and the load redistributes. But here's the ceiling. The maximum useful number of consumers equals the number of partitions. A 7th consumer on a 6-partition topic just sits idle. And remember, different consumer groups are completely independent. Each has its own bookmark into the same log. Now, a word about rebalancing, because it causes real pain. A rebalance is when Kafka reassigns partitions across the group, and it's triggered whenever a consumer joins or leaves. The problem? During a rebalance, all the consumers in the group pause. Everybody stops. That causes a lag spike. What triggers rebalances? A consumer crashing, a rolling deploy, or a consumer being too slow and blowing past its maximum pole interval, so Kafka assumes it's dead. The fix worth knowing: static group membership. You give each consumer a stable identity, so when it restarts, during a deploy say, it rejoins with the same ID and Kafka skips the full rebalance. Fewer pauses, fewer lag spikes. And finally, the feature that makes Kafka magical: replay. Because messages aren't deleted, a consumer can move its bookmark anywhere. Seek to the beginning to replay all of history. Seek to the end to skip the backlog and start fresh. Or seek to a specific timestamp to replay from, say, last Tuesday at noon. This is Kafka's superpower. Rerun a brand new machine learning model against 30 days of real history. Or recover cleanly from a bug that wrote bad data. Try doing that with a queue. So, producers choose durability and batching. Consumers choose their delivery guarantee through commit order. Groups give you scale, and replay gives you time travel. Next episode, we go to Kafka's most advanced and most interview-famous features, starting with true exactly once.